So today, during this presentation, I will talk about the use of semantic segmentation technology in our work. So it's a presentation about the EarthSignature and the EarthSearch platform. So during the presentation, I will mainly talk about EarthSignature first. So I will do a little overview, and after I will talk about the technical architecture. And after we will talk about the segmentation models and how do we expose the data with an API. And at the end, I will talk about the EarthSearch platform, which is a platform used in a search engine. So first of all, to understand what EarthSignature do, we have to understand what is a semantic segmentation. So I take a definition of it. Semantic image segmentation is a task of classifying each pixel in an image from a predefined set of classes. So here I take an example with two pictures. On the left, you can see the original pictures of a road with a pedestrian, traffic lights, cars, which could be different classes. And what semantic segmentation do is, for each of these classes, we give a color. So for the traffic lights, for example, it will be yellow. For the cars, it will be in, for the road, it will be in purple, and for the cars, it will be in blue. And it could be automatically done with machine learning. So machine learning take the original image on the left, and it give a segmentation on the right. So what we do is we don't do it for a road, we do it for satellite images. So what EarthSignature do is it takes data from Sentinel-2, from what Damien said about the Earth observation satellite. We process it into EarthSignature, and we compute the segmentation into EarthSignature. So you can see satellite image on the left and what could be the result on the right. And what we do is we try to expose this data to the different pilots to give different use cases. Still about the overview. So Sentinel-2 has a 5-day time resolution because there is 2 satellites, as Damien said. EarthSignature try to process daily images, so it's near real time. We get the segmentation close to every day, and we filter. There is a lot of images with clouds because there is clouds on Earth, and we filter images with a lot of clouds. When there is more than 60% of clouds on the images, we don't process it. For now, we cover the whole area of Europe for EarthSignature, and we store all the segmentation over time. So we keep it into a database, and you can request segmentation from 1 month ago in another time. I told you that semantic segmentation was about classifying a pixel into classes. So what we follow for EarthSignature is we follow the Korean land cover classification, which defines a lot of classes. As you can see, I don't know, there is 33 classes because there is a lot of things on Earth. So it could be from sea, airport, building, burn areas. And we try to give for each place on each pixel of the satellite images is classified into one of these classes. So you will see there is a lot of colors on the semantic segmentation images. And still about the overview, but a little bit more technical. So the technical infrastructure of EarthSignature is hosted by a Qwant server. We process first satellite images in parallel, and one image takes 45 minutes to process and to compute the segmentation. And approximately what we do is we do 100 images per day, depending of clouds, which is approximately what we need to do to cover Europe, which is basically 500 images of Sentinel-2 satellites. So now I will talk more about the architecture, the technical architecture. So what you have to understand from this picture is basically on the left square, it's a part of processing data from a cloud provider, which is named DIAS. They store a lot of images, satellite images in their own server, which are cloud accessible. So on the left, we process data and we do the segmentation with a machine learning model. So it's called an inference request. And on the right, it's more the storage and how do we expose the data. So once the satellite images is monitored and we have the segmentation, we store it into a database and we expose it with an API. So what I will do is I will mainly focus first on the left part about monitoring and the inference service. And after I will talk about the right part, which is the API and how do we expose the data. So what we do for the monitor service, what we do is we collect data from EODAG, which is a library developed by CS Group. It gives us a lot of all images with simple arguments. It takes data from different cloud providers. So we take one image, we process it with a Send-to-Core to make it more complex and more precise. After this pre-processing, we know exactly what is the coverage of clouds on the image. So if there is less, more than 60%, we remove it. And after, what we do is we chunk the image. We divide, because a satellite image is heavy, so we chunk it, we divide it in little parts, and we do the segmentation with the machine learning model. And after, we resample the image, and we store the segmentation into a PostGIS database, which is a Postgres database, but with an extension for geographical data. So to monitor all these pipelines, we have a new UI with Luigi, which gives us where we are, basically, because there is a lot of images, so we have to monitor a little bit. Here you can see there is 4 running tasks. So there is 3 of these tasks are running on the pre-processing, and there is another one that are doing the segmentation, which is a task called invert content. This way we can follow what was done, what task fails, why, So it's common to use to monitor pipelines and to know if something was wrong or if everything is running smoothly and everyone is happy. Okay. Now I will talk more about the segmentation models. So I talked before about the processing. Now I will talk mainly about how do we compute the segmentation. So we take a deep learning model trained on a ground truth example. So the model is trained over time. So EarthSignature has to handle multiple versions of models. Sometimes you want to try another model because you train it with other grounds, other data, so we can handle it, and we handle multiple versions of models. These models use our deep learning model, which is based on a UNet architecture. So basically, it's very it's very specific. But what we have to understand is this deep learning model has a lot of neurons, and it's very heavy. So to compute an images with this model, we need to use a GPU to be fast, because if you use a CPU, it could take hours to do the segmentation with this huge model. And we specifically use NVIDIA Triton Inference Server, which help us to do the inference of the model, because GPU basically is very good at doing computation in parallel. So it does a lot of computation, and it takes approximately 15 minutes to do the segmentation for one image. So yeah, basically what we do, I told you before, but what we do is we split the image. We split the image into little parts, because one satellite image is 4 gigabytes approximately. There is a lot of information, a lot of layers. There is not only RGB, there is also clouds, IR, other waves, and it's very heavy. So what we do is we split it in very small parts, and we give each of these parts into the GPU, because the GPU is very good when there is a lot of computation, not heavy, and we are limited with the memory about the GPU. So we divide it in a lot of parts, and after we resample of the results into the original shape of the image, and we store the data. Here you can see what could be, yes, what is the results. So at the top of the image, there is the ground truth, so what is really on the satellite images, and at the bottom you can see what was predicted by the segmentation, by the deep learning models. So sometimes it could be a little bit different, but what we do is when it's different, we try to train again and again to be closer of the ground truth. But mainly what we can see is sometimes it's not as precise as the truth, but it mainly gives the correct information about what is on the satellite image. And basically, as I said before, each color represents a classes. So you can see the red, the blue. The blue is probably water. The red is urban buildings. So it gives with colors what are on the satellite image. Now I will talk about the API. So how do we expose data to pilots? So we used gRPC API, which is not very common. Satellite images, as I said, are heavy, and we need optimized process to use it and to give the information. So gRPC was developed by Google, which used protobuf. Basically, it used binary data, which is on code and which could be decoded by the client. And it's very optimized for our purpose. We have two versions of the API. There is both of the versions could be used simultaneously. The first one is for raster images. So basically, when you request the V1, you directly get the segmentation image. And it's a little bit heavy because it could take some time to take this data. And we implement the V2. V2 is lighter. It used polygons, GeoJSON polygons, and it takes less time to get the data. But V1 is still simpler to use, even if it is a little bit longer to request the data, and V2 needs to implement your own client to collect the data, even if it is fast. So what we do is we have a domain name called EarthSignature SnapEarth.eu at the port 443. If you request this endpoint, this domain name, you can have access to 3 endpoints for each of the V1 or V2 API. What is more important is 2 endpoints. The first one is the list products. Basically, when you request the list products endpoint, it will give you all the available data we have into the database, so all the satellite images that have been processed. And when you call the list segmentation endpoint, it will give you the raster or the segmentation data. So when you call the API, for example, the list segmentation endpoint, you can play with some parameters to filter data, because we have a lot of images in the database. So you can filter with the WKT parameter. So WKT is you give a polygon area, and we return only images within this area. You can filter with date, so with a start date and an end date parameter. You can filter with product IDs. So if you know you want this satellite images segmentation, and you have the ID, the identifier, you can directly give the identifier to get this specific segmentation. You can filter by categories. If you only want water or something, I don't know, burn areas, satellite images with burn areas, you can say, okay, I just want categories number 433, and you will get only satellite images with burn areas. And the last is the maximum number of results. Basically, if you just want 1 or 2 results, you say, okay, I just want n results equal to 1, and you will get one result. All the guidelines and examples are on the following links. There is basically instruction for Windows user and also for Linux and Mac user. I am on Linux, so it's a little bit easier on Linux, but on Windows it also works. There's several steps to follow, but once it should be working. So what I will do is I will show you a little demo of EarthSignature. So from Linux. Wow, so this is all the satellite images running. So what I do is I use a terminal with command line. I use gRPC URL to request the data with some parameter. So parameters are here. I say, okay, I just want one satellite images with this identifier because I know this is a nice satellite image. I request this endpoint. Sorry, I request this domain with this endpoint, this segmentation. And what I do after is I filter basically. I filter the response to this field. I decode the data because it's encrypted to be faster, and I put it into a file which is called Hackathon Demo Lisbon. So it's running. I do the request. And because it's the V1 API and I request directly raster data, it's a little bit longer than the V2, but for it's easier to use. So I am showing this this example. So yes, it takes 30 seconds. I get the return. Where is my image? Okay, sorry. Okay, Hackathon Lisbon. Oh, it's it. So what I use is I use QGIS to show you the satellite image. What I do is I add a new layer here, and okay, I give a projection. So here, okay, I request the data close to Lisbon, on Lisbon. Okay, what I do is maybe to be more beautiful, I can use, okay, pop up. Let's go, apply. Okay, so here each classes, you can see basically the satellite image. There is a mass cloud. So here on the original image, there is a cloud, so we don't analyze it. And for others, part of the satellite image, here you can see there is a value, 523. Here another value, and for each value I give a color, basically, and it shows when I remove it. Okay, we see from the OpenStreetMap style what was under this satellite images, and as you can see, it represents what was on Earth. So here there is water. We get the correct category, and extra for other parts. Here close to Lisbon there is more building, so they are in red, which is another category from the Qwant non-cover classification with the value of 122. Cool. Up. Oh no, I have to. I'm coming back at the end of the presentation. Yes, here I am. And okay, so I did you a little demonstration about EarthSignature, and now I will talk about EarthSearch, which will be fast. So basically, I am working at Qwant, which is an European search engine, which respects the privacy. And what we do is we trigger, we show satellite images depending of some requests the user did. And basically, it gives access of the SnapEarth satellite images and the segmentation to the general public, because there is no satellite images user that use Qwant. And here you can see the Semantic image with a link of the original image. And where is the image and what are the places you see, and that depends. That images was triggered because we are at the location of Lisbon, so that was the image that I showed you before, and the user search for an image satellites. And we also do filtering with categories. So if you say image satellite Lisbon forest, it will search for a satellite image with a forest inside. To conclude, basically, what EarthSignature do is a real-time satellite segmentation images that give data for other projects. There is a lot of optimization basically in EarthSignature because satellite images are heavy. So during all the process, the pipelines, we try to optimize data to give the better experience to the users. And EarthSearch is used to display satellite images for the general publics. And I think that's it. Thank you very much for your attention. You have my mail if you have some requests, if the platform has some trouble, or if you have some question, do not hesitate.
Yes, thank you very much, Sebastian, for your presentation. I see a question from Pavel in the chat.
So during the first question, thank you, Pavel. During the image processing, do you geometrically align the occasionally shift Sentinel-2B since I'm not sure to understand, because what we do only during the pre-processing is we use Send-to-Core, which not really align data. It only takes the original shape and it tries to give more layers, more information about this the shape, but it doesn't change the shape or shift anything about polygons or because there is something specific to Sentinel-2B satellite. Okay, but I didn't really understand the question, because it means maybe Sentinel-2B satellites have a specific behavior, and if Send-to-Core do it, probably it will correct it will align the shift, but I'm not aware of it. I trust Send-to-Core. And the second is, what kind of ground truth data you use to train the model? So basically, I was not working on the model, but basically, some people.
Sebastian, I'm Gökberk back from Meta. I can quickly comment on that. So we have multiple models, but the currently deployed one is based on coastal zone annotations. I don't know about this. It's because it's infrastructure related question rather than model. I also don't have the answer for the pre-processing done in the current system, but for the second one, it's coastal zones for the current model.
Yeah, about the processing question, basically we use the last version of Sentinel Send-to-Core, so it's probably take into account. I hope, but I need to see the documentation of Send-to-Core. Thank you, Gunther, for your help.